All right, so in this video, I'm going to cover section 2.6. That's the last section of chapter 2. Um, so, all right, so here, as you can see that I'm gonna cover 2.6 by the PowerPoint. So 2.6, we're gonna learn the constructing functions with the variation. It sounds like a little bit abstract, but actually we're gonna learn the four different type of variations. So the first one, as you can see, the direct variation. Next one, the inverse variation. The third one is the joint variation, and then last one is combined variation. So here we're gonna talk about this. We wanna construct the mathematical equation representing a relationship between two variables x and y in a real world problems. So when you get the word problems and you see the y varies directly as x. I mean, depending on problems, you may see other variable than y and x. So for example, the cost varies directly as the size of house, something like this, or yeah, so a variable, in a the one of the variable varies directly as the other variable. Okay, so when you see something variable varies directly as the other variable, or the variable one of the variable is directly proportional to the other variable, then we can set the equation as like this: y equals k times x. Okay, so let's see example. So example 1. So the cost C of a house in a Westwood estate is directly proportional to the size of the house S. So you see that here, the problems introduced to the variable cost of house and size of house, C and S, right? So the problem says that the cost of house is directly proportional to the size of house S. So we can say this, then we can use direct derivation. Okay, what we just saw, in previous slide. So C is equal to K times X. But what is a K? K is a constant, can be figured out by the substituting specific number into y and x. In this problem, C and S, right? So normally the problems give you those numbers so that we can figure out K. So it's in the example 1, if a 2,850 square foot house costs 182,400, 182,400. So then what is the cost of 3640 square foot house? So you see that here, the cost of the what? See that cost of house 182,400 and then 2,850. So we're gonna plug in these two numbers into CNS in the equation so that we can figure out K, and then and then we find out the cost of the house. The size is 3640. Okay, so let me do this. Give me a second. All right. So example 1. All right. So the C, we got the C is equal to K times S, right? Okay. Then the cost of house, whose size is 2,850 is 18240. So 182 and then 400. Okay. So 182K is equal to K times the size is 2,850, right? Okay. So the K is what? The K is gonna be 182,400 and divided by 2,850. Okay. So let me use a calculator to figure out the fraction, to simplify a fraction. Okay. So 182,400 right here. 400 and then divide by 2 K50. Okay, so we got 64. So this is equal to 64. Right. So now we got the C is equal to 64 times S. What does that mean? It means that the as S is increased, then this how the size of house is increased, then C the cost is increased by multiple of 64 by S. Okay, so 64 times of the S. Okay, so that's the meaning of this. So now then we want to figure out, the question is this: what is the cost of a 3,640 square foot house? So we plug in that size into the S. Then C is equal to 64 times and 3640. Okay. So now this is using calculator. So 64 times 3640. We got the 232960. Okay. So 232,960. Okay. Okay. So that's example one. And then so now let's say try these problems. Okay. So in try this problem, the cost of a smoothie is directly proportional to the its size. We see that the cost is directly proportional to its size. So the problems give you the what the relationship between two variable cost and size, right, of the smoothie. So if a 12-ounce smoothie is a $3.60, then what is the cost of the 16-ounce smoothie? Okay, so yeah, definitely we're gonna use the directed variation, right? And then to find the k, so we used what that information. 12-ounce smoothie is $3.06. Okay, right. So I'll try these problems. Okay, so let me use this. C is equal to k times s. So what is C? C is the cost of smoothie. Okay, and then s means the size. The size of maybe the size of cup. Okay, so now then the $3.60, 3.60 is equal to k times 12. Okay, so it costs $3.06 when maybe you order the 12-ounce smoothie. Okay, so now k is what? It's gonna be 3.60 divided by 12, right? So 3.60 divided by 12. That's gonna be 0.3. Okay. So now then so we want to figure out cost of 16 on smoothie. So we plug in 16 into S. Okay. So C is equal to 0.3. This is K. Okay. That's K times the size of smoothie is 16. Okay. So 0.3 times 16. This is 48, right? Okay. 4.8. Sorry. 0.3 times 16. The 4.8. So it costs $4.80. Okay. So that's the directed variations. So now next one, back to the previous slide. By the way, directed variations. So if you so in directed variations, the when you look at the equation y equals kx, it means this: x is increased, the y is increased, uh, the what as multiple of k times, okay, as x is increased. Okay, so but in the inverse variation is opposite. One of the variable increase, the other variable decrease. If one of the variables is decreased, then the other variables increase. Okay, this that is called inverse variation. How can you express that in regions? The between two variable, one increase, the other one decrease. One decrease, the other one is increase. Then the mathematical expression of that is this: y equals k over x. So since x is in the denominator, as x is increased, that fraction is decreased. It makes sense, right? So let's see example. So see example two. The time it takes to remove all of the campaign sign in Bakersfield after election varies. You see that varies inversely with the number of volunteers working on the job. So it makes sense. In the volunteers, you know, um, there are more and more volunteers. Then the time it takes to remove going to be decreased, right? It makes sense. So let's solve these problems. Okay. So the question is this: how many days would it take for 15 volunteers? We want to figure out how long does it take to remove all the campaign sign when 15 volunteers are going to involved. So, all right. So example two. So let's say t is the time to take the remove. Okay. So the time to, it takes to remove all the campaign sign. Okay. And let's say n is the number of volunteers. Okay. So now then, the t is equal to, we can say k over n, you see? Okay, because the problem says that, well, the time varies inversely with the number of volunteers. And then they give information to find, okay, so 12 volunteers could complete the job in 7 days. So we plug in 7 into t. Here we can figure out that what the unit of time is days. Okay, so 7 is equal to k over n is a 12, right? So k is what? 7 times 12, right? Okay. So 84, right? Now then, so we are ready to solve the problems. So how many days would it take for 15 volunteers? So we plug in 15 into n, and then we plug in 84 into k. Okay. So 84 divided by 15, that's the 5.6. Okay, so it's 5.6 days. Okay, it means the 5 days. 0.6 days means the what? 1 day is 24 hours. So 0.6 what? The days means the 4 hours, right? So oh no, 6 hours, sorry. So 5 days, 6 hours. Okay. Now let's see, try these problems. So the time required to rake the ground at Rockwood Manor varies inversely. You see that varies inversely with the number of rakers. So if 4 rakers can complete the job in 12 hours, then how long would it take for 6 rakers to complete the job? All right, so now let's see. So similarly, to example 2, we say t is equal to k over, let me say, yeah, n. Okay, so here t is the time required to rake the ground at the manor, and then the n is the number of rakers. Okay, then 4 rakers can complete the job in 12 hours. So here the unit of time is hours. Okay, sometimes the day and unit, um, they are involved in the problems at the same time. Maybe it, the for example, if 5 rakers can complete the job in 1 day and 12 hours, then you have to unify the unit of the time. Okay, so day or the hours. Okay, so if you want to use unify the time, all the unit of time is just day, then you have to convert the 12 hours to day. Okay, so 12 hours is a 0.5 day, right? So 1 day 12 hours means that 1.5 days. Okay, so now but fortunately the example 2 and try these problems, they just use a day or hours, right? They don't mix them up. Okay, used. So the k gonna be what? The k gonna be 4 times 12, right? Okay, so 48. Okay, and now then what? We gonna see the question. How long would it take for 6 rakers? Let's see. Yeah, 6 records to complete the job. So we plug in 6 into n. Okay. And then t is equal to 48. We just got k, which is 48, and the over n is what? Number of records, which is 6. So this is 8, right? So 8 hours. It's gonna take 8 hours, okay, to complete the job using 6 records. Okay, so now next one. See the joint and combined variation. So let's see. So the statement y, a joint variation, the statement y varies jointly as x and z. So you see that 3 variables are coupled. Okay, and the y vary if one of variables varies jointly as the the other 2 variables x and z, that is called joint variation, and then mathematically we can express it as like this: y is equal to k times x times z. Okay, so combined variation is the 2 direct variation, inverse variation. 2 variations are coupled. Okay, then we say that is combined variation. So let's see example 3. Okay, and try these problems. Example 3. The cost of constructing a 9-foot by 12-foot patio is $734.40. Okay, so if the cost varies jointly, you see that cost varies jointly. So this is joint problems about that problem is about the joint variation, right? So cost varies jointly as the length and width. So 3 variables are coupled: cost, length, and width. Okay, so then what does an 8-foot by 14-foot patio cost? Okay, let's see. So example 3. So C is equal to, okay, you can say K times and the L times W. So I use the letter C, capital letter C for the cost. Okay, I used L, and for the, guess what, length, right? The length of the patio, and then W is width. Okay, so now to find that K, I'm going to plug in 9, 12, and then 734.40. Okay, so now let's see. 734.40 is equal to K times and 9 times 12. Okay, so the K is what? Going to be 734.40 divided by 9 times 12. Okay, so 734.40 and then divided by 9 times 12. Okay, that is. So now we're going to get the 6.8. Okay, so this is 6.8. All right, so now let's see other question. What does an 8-foot by 14-foot patio cost? So C is going to be 6.8 times and 8 times 14. Okay, so let's see. This is 6.8 times 8 times 14. That's going to be 761.6. Okay, so it's going to cost $761.06. Okay. Let's try these problems. It's similar to example 3. So cost of fence that is 200 feet long and 5 feet high, $3,000. So now give me a second. Yeah, let me read. All right, so the cost of the fence that is 200 feet long and the 5 feet high is $3,000. So if the cost vary jointly with the length and height, then what is the cost of fence that is 250 feet long and 6 feet high? Okay, so now then, let's see. You can say C is equal to K times L times, let me use H, okay? So guess what? The C is means the height of the cost, I'm sorry, the cost, and then length is, L means length, and then H means what? Height. Okay. So, okay. Now then what? Oops. Okay. So now what? We gonna plug in 205 and 3,000 into the equation. Okay. So $3,000 is equal to K times the 200. That's the length of the fence, and then height is 5 feet. So k gonna be 3000 over 200 times 5, right? So I think we can do this one by hand. So 0, 0 cancels them out, top and bottom 1. Okay, 2 times 5 is 10. So 30 over 10 is 3, right? So now then what? The c is equal to 3 over, we just get k, which is 3, right? Over, the question is this, what is the cost of fence that is 2, oops, c is equal to 3 times, right? Then what is the cost of fence that is 250 long and 6 feet high? Okay, so we do this 3 times 250 times 6, okay, which is $4,500. Okay, that's the answer. All right. So 2.6 is really short, okay, and the objective is just the uh, you know to know how to use the direct variation, inverse variation, and then the joint variation, and then combined variation. So the problems about combined variation, we're going to see this one next time. Okay, so this is for 2.6. Okay, the next time I'm gonna see a couple of the more problems about combined variation and then joint variations, and then I'm gonna cover 3.1. Okay, so that's for today.